Okay, so let's try to fix some more stuff. So when we give this a run for a second, let's give this a run. Is this incriminating? No, it's not incriminating. I guess we didn't have to run this because we have a screenshot here. So these 4 pixels that we're zoomed into, well, not 4 pixels exactly. Here, well, we'll open this up and then we'll... Okay, so I'm going to press U. I'm going to go over here. So what you're seeing is 8 pixels, right? No, 16? 4 pixels, that 8, that's 16, yeah. So there's 16 total pixels in these corners, right? 4 pixels in each corner. And we're trying to zoom into these, and we're trying to have these pixels, these clusters of 4, we want them snapped exactly to the corner. And you can see that it's not snapped exactly to the corner, right? There's some type of nonsense going on here, and I don't know exactly what's going on. But we have to... It has something to do with my range mapping. Now, one thing we could do is we could actually inspect the actual... like, if we inspect the actual image, we're expecting that... Let's open up getting close. This is called getting closer, right? We're expecting... What am I expecting? I believe I'm expecting this to be like exactly 16 by 16 right here. And I'm going to guess that it's maybe like... I don't even know anymore. But let's see if that's correct. So, yeah, 16 by 16. Okay, cool. And then I'm going to guess this is like half. I'm going to guess this is like... That doesn't look like 8. File new. It's 9 by 9, so that's not quite that, right? What about here? Is anything off by 1 pixel over here? Like, are we finding anything that's like 17 by 17, right? So, because I think somewhere in the calculations, we're using up an extra... No, it doesn't. That doesn't look off either. So the question is, where is this correct, or are we mistaken somewhere? Like, what's going on here? So let's just copy this for a second. And let's start measuring things out and see if possibly we have made some logical error, right? So maybe there is the possibility that we've just made a logical error, and the reason it's not rendering how we expect it to be rendering is not because the logic is now incorrect, but it's because we're making some type of fallacy in the way we've decided things need to be done. So I don't know, let's use a yellow here. And let's block out these corners. And then let's fill this with, I don't know, like a gray or something. And maybe turn anti-aliasing off so it doesn't do that nonsense. Okay, let's take this. Let's go over here and let's just start, let's start trying to measure things out here, right? So, like why do we have... Because what I'm expecting, I was expecting something to be like this, right? So where we have, like, something that goes here, and then I'm expecting, like, 16 of these, right? And that's not what we're getting, so maybe we can kind of measure this out and try to figure out what's going on. Right. And then there's a test we can write as well. We could write some test code as well to help with this. But let's just do this for now. Just hackishly kind of throw this in here. And then start taking count of what we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We got 16 things. So that tells me that there's some spread between here, right? So this is getting pushed a little bit further out, and this is getting pushed a little bit further out. I mean, that's what it visually looks like. That doesn't mean that that's necessarily what's happening. It could be some type of effect of a rounding error that's doing that, right? Because we turned our seal into a... We turned our Oh, that's interesting. So we turned our... Originally we were flooring, and now we decided, hey, let's take that floor, and let's turn it into a round. And the round is even closer to correct than the floor was. So is there the possibility that if we're halfway to correct with a round, and a round goes either way, it's seals or floors, depending which one's closest, maybe to get the math working correctly, all we have to do is we have to change the round to a seal, right? Because originally we were flooring and we were way off. Now we're rounding and we're kind of halfway closer. Maybe if we just, all we got to do is seal, right? So maybe seal. So let's, yeah, so I think that it was good to kind of like take some time and just inspect this image and do this, because I think it gave my mind some time to, you know, think it out a bit. So let's just go in for the kill and say, you know what, I think that might actually result in something, right? And the test cases actually might fail, though, if we add a seal in instead of a round. So we may want to comment the test code out, because we may find that the viewport ends up looking more correct, but the test will fail, right? So, so whatever gets us the results that look correct is going to be what we're going to assume is the correct code, right? We're doing a whole bunch of math as well. But when we're like off by 1 and whatnot, if we're off by 1 with calculations, and we don't know which calculation to choose, we're going to choose the calculation that gets us something that looks correct. That's just the way I'm going to do it. So we have this round native and round F32. So let's kind of keep up with that naming convention, right? So let's define something like, right, seal. Instead of like C like that, seal. I think that's kind of harder to see. So I think cell for seal makes more sense. So seal native. That's going to be seal. I believe we just got to call it seal. I believe GLSL has a seal command. Yeah, see, there's a seal in GLSL. So we're going to have a native seal, and then we're going to have a seal F32, right? So seal F32 takes a float 32 and returns an int 32, right? That's the idea. Okay, and then let's put this over here for a second so we can make sure our screen looks correct. Cool. And then here we can kind of just duplicate this, right? Duplicate this and turn round to CEL. And then right here, this is CEL. So we got seal native, seal float 32. Seal native, seal float 32. And this has to be something here. So we kind of threw this in. So we're going to call this AAC 2020 fragcom seal F32. Right? So it's going to take a float 32 and return it int 32, right? So we're going to take this. This is another one of our like little helper functions, so let's just add it in here, right? So we're going to say, do it the same way we did the other code, right? So int 32, something something, float 32, called float 32, and we're going to return, and we're going to say make int 32, and then we're going to seal native, right? We're going to use the native seal command on the float 32. And that's it. We're done, right? We have the little helper function for this seal command here. Okay. Let's actually undefine the seal native and the seal float 32 that we've kind of added in here, right? So down here, let's kind of duplicate this line twice. And then we want 11 and a 12. And native and F32 is what they're called, right? So seal native and seal float 32. Excellent. And this is supposed to be a 12 here. Okay, so now the next thing is, let's go into the... So we've already added this, right? We already added this. So now we have to add poly OGL seal native and poly OGL seal F32, right? So in polyfills stuff here. Let's take this for a second and let's indent this a bit, because it's kind of, these are kind of subsections, right? These are right, so this is a GLSL polyfill round, right? And maybe we want to make this, we use kind of thicker lines for everything else, so maybe we want to do that. And then down at the end of the section, right, we can do the same thing, right? So GLSL polyfills round, right? And then what we can do is we can steal all this code and we can just rewrite a version of this that is for sealing, right? So let's just file new and just paste this here so we have a place to work. And let's just go find anywhere we see round, and we're just going to replace rounds with seals, right? So round, we're going to call that seal. And then over here we got this thing that says round. We're just going to say seal. And I don't know if there's like a native seal command in math.h. We'll find out though, right? Like, cause it'll not compile on us. We'll just try to do that and just see what happens. So seal native, seal, seal, and seal. Okay. So now that we have this, where we have this ROU for round native or whatever, this is going to be called CEL for seal native. It's going to be CEL for seal native as well. And this is going to be, sorry, seal float 32, my bad. Seal float 32, etc. Yeah, seal native, polyfill, seal. There's no, the word round is not in here, right? Round is not in here. Let's take that. That looks good. And let's just insert that here, right? And so now we have kind of like we have a seal. We have the seal section, and then we have this round section. And you know what? We still have some room, so why don't we kind of like subdivide this one more time, right? So let's kind of like double. Because we have enough room where we can double indent like this. And that way what we can do is we can make it a little more obvious that these functions are all kind of logically grouped together, right? So I just want to give it some indentation that kind of communicates the grouping of the functions. So okay. So now that we have this, we can do this, right? We can create a GLSL polyfill seal and round, maybe. So for now, if we create a floor later, put that code here. Right, so if we create a floor command, we'll also put it in this section, but right now we don't have that. So we'll go down here and we'll just cap this off, right? So we'll take this section divider here, and we'll just throw that there, and boom, we got seal and round, right? GLSL polyfill seal and round. So we got the seal section first, right? So seal, and then we have the round section, right? So the next thing we could do is we could kind of like do a little dash line I1 x64 to just kind of like communicate the separation of the little function sections within here, right? So we could do this, right? Right, so now we have these different function sections within this section, right? We have sections within sections. We're just kind of like perforating the sections. I don't know, it's kind of like artsy, but I don't know, I just like to have this visual division between what I'm doing here. So that indentation is all nice and well, but it's making things a little bit harder for us. So let's just put our int32 cast like kind of up here. And then we want to do the same thing with, let's also put this over here like that, right? So int32 cast. Yeah, let's write it like that. I think that looks a little bit better. So let's just steal this from here, right? Paste that down there. Paste this closing bracket over here. And that looks a little bit more acceptable for me, I think. Okay, cool. So now that we have all that, we can kind of clean this up and say, you know what, we don't need this extra space right here. It's not giving us anything. It's just making things a little bit hard to follow. Okay, cool. So let's give this a run. And... oh, hold on. So we're not done yet. Well, actually, let's just make sure it compiles, right? Let's make sure it compiles. And then we're going to swap out the rounding commands for the seal commands that we're using. So, expected something something 110. So let's go at 110 and see where we screwed up here. Okay, so that looks like... oh, this is the fragment shader code. Okay, hold on. So it's not this code. So in 110, let's go look at 110 for a second. Int32, yeah, so we just forgot to open up our braces there. It looks like that's all we did. I think that's the only mistake. Well, we'll see what happens. So let's just put this over here. But, and then once it compiles, we want to just swap out our rounding for our sealing and see if we get better results. Because we're not actually going to see any results yet because we haven't actually changed the functionality. Now the thing is that if we are to change, so in the GPUView code here, right, we have... actually, no, it's in Fragment Shader Common, sorry. In Fragment Shader Common, that's where we're doing this range mapping here. And so we're thinking, instead of round float 32, we're thinking, hey, maybe what we really need is seal float 32, right? So seal float 32. Maybe that will get us closer to code that looks correct, right? So we're just going to give it a shot because we've already tried with flooring, we've already tried with rounding. And rounding got us a little bit closer, so therefore sealing might get us exactly where we want to be. Now, it could possibly mean that it's gonna change the behavior of things, so our test code might fail. And we might want to just quickly comment out all that test code we've written and see if the results actually look more like what we want them to look like. Because if the results actually look correct, then I'm going to assume the test code is incorrect. For whatever it is that may have failed, I will just assume that it is the test code that is not true. So let's go into here, right? So here's where we're writing all this test stuff for this rectangle mapping. And let's go in here, let's just, right now, we're just going to comment it all out so we can see, well, what does the code look like when it runs? Because maybe when we run this, it's actually going to look a lot, it may look actually a lot better, right? And I don't know if that's true. I have to think more deeply about my formulas. I have to write more intense tests. But let's give it a shot because we might actually see something that looks correct. So let's go over here. That looks a lot less, what do you call it? That looks less. So we're getting this corner in, but then we're still losing this corner. So this looks kind of like more wrong to me, I think. I think the rounding is closer to what we want. So I'm going to put the rounding back in. I think that it was a good shot. It was a good guess, but it's not no. So right here we're just going to say, round float 32 seems to be the most correct thing to do here. And Yeah, so let's just do round float 32, round float 32, round float 32. Let's put that in there like that. And then let's just give that a run. And all our tests should pass. And then we're going to make a specific case for number 3, right? So we think that we would like to set up this situation here where we have like a very large canvas, and we're trying to do some texture sampling to map these kind of squares onto the canvas, right? So let's try to do that. So we have 4 pixels in each corner, and then we have some like dead space in the middle, right? So we got this dead space in the middle, and then we got these 4 corners that need to be snapped. And that's not what we're seeing, right? So let's actually copy this. Let's copy all this, paste that, and we're going to call this SC3, right, for a specific case number 3. And are these cases already in order? They're kind of written in order, so I guess we should probably just keep it in order. I don't know. I'm not too picky about it. Okay. So we want to first create like a diagram to represent what test case we're actually thinking about. Like what are we trying to accomplish, right? So if we go to so first let's go open up that image that is very close to what we want. Okay, so this image right here, let me open this up. Okay, let me put this down here for a second. So this thing right here is pretty close to what we want, but it represents the test case that we need to test for, right? Where we're rendering a little bit of this pixel, but not all of it, and then we're rendering this full pixel. So that means that when we're trying to map to the pixels, you don't just want to map, you know, one data point to this pixel and one data point to this pixel. We need to do like at least 4 different data points for each pixel. So let's go look at the test cases that we can write. Or first, before we write the test cases, let's try to figure out, well, what kind of diagram can we write where we can figure this out, right? So we want to say, okay, we want to sample from something where there's like 4 pixels, right? And then there's some stuff in the middle, right? So we could map something like this, right? I think that's the easiest way to conceptualize what's going on. Is that here is the texture that has less resolution that we're mapping to. Right? So destination texture to. So this is the destination texture to sample right here, right? So we have a smaller texture, and then we have like a larger amount of frag chords. Actually, the way this is currently set up, this test, the way we're actually trying to render, we actually have a 1-to-1, but let's not worry about, well, not quite. Well, as far as the selection rectangle is concerned, we don't have a one. Never mind. I'm thinking of some things. Don't worry about what I'm saying. Okay, so we need a area of data points a little bit bigger than this so that we can, right? So the output. So 1, 2, 3, 4 pixels, unique pixels here. 1, 2, 3, 4 unique pixels here. 1, 2, 3, 4 unique pixels here, etc., etc. And we want to make sure that on screen we want to be able to sample this pixel, this pixel, this pixel, and this pixel a minimum of each pixel we want to sample a minimum of 4 times, right? Because 2 times per axis. So what I'm thinking is we take that and we say, okay, well, 2 times per axis means that each pixel needs to be the minimum that we could do this for, where everything kind of goes in evenly. Right? If we want to get this working, we can take like this kind of pattern here. Right? So scanning through these coordinates, right? These 4 coordinates up here should map nicely to here, right? So let's make a note here. So at vid IID, is it 39 or are we supposed to be in another video? No, it is 139, the video number. And the time is, 0 hours, 26 minutes, and, I don't know, 13 seconds for, lucky numbers. Figuring out the problem by looking at Imgur image on my left monitor. We want to scan over a large screen / source Okay, so I have a little description of what we're talking about down here in this diagram. And so right here is the source screen size set of frag chords. Right, so this is a set of frag chords, and we have partitioned it in a layout, right? We've given some visual space to the grouping of pixels, so that it's a little bit easier to understand what's going on here, right? So the next thing we can do is we can measure this out. So we could say, this is a set of frag chords. Let's just like put a little line here like this. Like, here's a little line. And then down here, or underscores plus underscores. So this right here is 4, 4, and 4, so 12, right? Okay. And then, let's call it 0, 1, 12. Even though that technically would be octal, so that might confuse some people, but 12, right? And then it's square, so let's not bother labeling the other axis. But this is the texture sample, so this is going to be so this right here, we can steal this from here. Steal this from here, paste it there. So this would be 2, 4, 6, right? So 6. So we got 12 and 6 like this. Let's remove the 0. I changed my mind on that. So we got 12 and 6. And the question is, what is the question? What are we trying to do? This is inside of a commented out area, so let's not do that. Let's just do this. Well, it's actually not a commented out area yet, but we're about to comment it out. But yeah, we want to map from here to here, right? So we can see that we got, you know, this would be, since it's 12, this would be, you know, this would be 0. It would be, you know, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Here we're talking about the mapping of the coordinates, right? That is how it would roll, right? In terms of mapping each one of these pixels, right? And then for over here, 0 to 11, this is going to be, you know, 0, 1, 2, 3, 4, and 5. Okay. And those are going to be here, 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 and here. Okay. So, now that we have that, we know kind of what the ranges are. You can kind of just steal this code, right? We can steal all these calculations, right? Because we have a very specific case, right? This function is for this exact case, and we can. Now we do have like a lot of pixels though, right? Because we want this one, this one, this one, and this one, right? We want all these pixels, so it might be better just to make a table, right? Because this is getting kind of beefy here. And we can say, you know, int32 table UTC table of unit test code equals, and let's concentrate on just the diagonals, right? We don't really have to. So we just care about. Well, actually, let's go overkill. Let's go overkill and make sure that like every single one of these points get tested. Every single one of these points get tested. Every single one of these. Maybe we just want to go like completely overkill and make absolutely sure, right? That would be a big decent chunk of stuff though. Like, do we really want to go that overkill? Right? Do we really want to go that overkill when possibly just doing the diagonals, right? Doing the diagonal here and the diagonal here might be good enough, right? The diagonals here and the diagonals here, right? You don't have to do all that stuff, right? It would save us a lot of work, because 16 and 16 is, right, 32. And that would be 64 different tests, right? So that's 64 lines of code. Well, let's think about it. What are the inputs? What are the outputs? We know that all the tests are going to have the exact same ranges, right? So we only are worried about, okay, here's our input coordinates, here's our output coordinates, right? So we can make this unit test table a little bit smaller than before, right? We can say, you know, we have 0, 0 for the input, and then for the output. Well, let's do this. 0, 0. And then over here, we want 0, 0. And we're never going to have anything more than a 2-digit output value, right? Because looking at this, we can see all the coordinates. There's double digits, but they're never triple digits, right? So this is like one test case worth of data, right? And so what we could just do is say, you know what, let's just go through all these things and make sure they map correctly. So we got on the X, we're going to go 0, 1, 2, and 3, right? 0, 1, 2, and 3. And keep the Y 0. And then we're going to expect that to output to, we're going to expect that to map to 0, 0, and then 1, 1, right? So 0, 0, and then map to 1, 1 like that. That's kind of what we're expecting. And we can say that this is... Right, then we want to just increase the stride to go down to the next level. So we'll make this like a 1, right? We'll make this a 1, and if it's a 1, it's still mapping to this first pixel here, right? So it's still a 0. And so that's all we need. So then we can copy this, right? We can copy all this, we can paste it. And so we got 0, 1, 2, and 3. So 2 and 3. And now we need to sample from the next pixel down, right? So these should be 1s here, right? So so that is all the tests for mapping from here to here, right? So it's not actually that bad to like explicitly spell this out, right? So we can say, you know, we can make a little diagram here. We can make some, here, we could do this. So we could, right, this is top left. Do not like this font. Language, settings, style configurator, Monaco. How about Andale Mono? Andale Mono makes the diagrams a little bit easier to... Okay, I think Andale Mono for today, because I think that makes it a little bit easier to look at. But yeah, so this is top left, and then, you know, over here would be the top right. And we're gonna test each one of these sections in order, right? So we're gonna do top left, we're gonna do top right, and then we're gonna do the bottoms, right? So we're gonna go over here to here, and we're just gonna say, hey, what should this be, right? So this is gonna be bottom right, or bottom left, because I can't do my left and right. And then over here, we wanna just say point to here and say, hey, this is the bottom right. Okay, so now that we have this diagrammed out and we know we've done the top left test, we can say, we can literally just segment this out and say TL, right? So we could actually mark this as the top left tests. And also, we have enough room to where we could indent this a little bit more if we wanted to, right? So we could say, okay, that looks better. Okay, so this is the top left. Right, so these tests are top left. And we want to mark off the end of the top left section. And we have 16 tests here, right? 4, 4, 8, 8, 16, right? So this table of unit test code needs to have a number. So number of tests and number of columns, right? And the number of columns is 4, so let's just put a 4 in here. I don't think I need to... Okay, so we have the inputs and the outputs, right? So we can extract those, and we can say that when we're going through these tests, right? Let's close this off. We didn't close this off, did we? So for, you know, test index equals 0, test index is less than or equal to the max index, and then test index is plus plus. This is the basic testing. And we want to extract values, so we want to extract the, we could just run it, right? We could just run, no, let's actually do it. So, source x equals test index base plus 0. Right, so we have source and destination, right? So, destination x and y, source x and y. So, and it's all contiguous, so 1, 2, and 3. Okay. So, source x, and this is source y. And then over here, is our destination X and our destination Y. Okay, so after that, the bounds are the same for all the function calls, and that's why we're not actually putting that into this test code, right? We're not going to put the bounds in the test table because the test table does not need that, right? The test table, like if we look at this function call, we're going to just steal this function call here, and we're just going to throw it down here for a second. So we got this remapping function call, and the input range and output range, we can just hard code this, and then we can use, this is the source X, right? So source X, source Y, source XY location to map, right? So this is the source XY location that we're going to map, and then here's the input and output range right here, right? So we can, if we really want, well, no, let's not get too fancy here. Let's just write it like this. Yeah, that's fine. We can write it tersely like that. So let's go up here and define some things somewhere. So how about, you know, I don't know where I want to put it. We could just say, you know, now, I like that comment there. I guess here, sure. Well, I like the test table up at the top. I guess here makes the most sense. Okay, so anyways, int32 source X. Let's do source X, int32 source Y, destination X, destination Y, int32 test index, int32 max index, and int32 base. Alright, so max index equals number of tests times 4, because the stride, there's 4 elements per test, and then a -1, right? Because it's the max inclusive index. Okay. Now the base value, we still have to calculate the base value, and the base value is pretty easy. The base value, the base offset to the first element in the test is the test index times 4, right? So actually, let's make that number of elements, or number of columns, because right now that just makes, this is just making it harder to read. Like, the magic number was doing it for me for a while, but number of tests times number of columns, because right, test index times the number of columns, the stride basically, and then over here number of columns as well, and then we can go up to here at the top of the function, or we could go I don't know where we want to do it. Well, here's where we define the array. So right here we could say, you know, define number of tests, and that right now is 16, and then define the number of columns. The number of columns is, I said 4, right? And there, yep, there's 4 there. So number of tests, number of columns. And then down here, we need it all the way down to here, and we're using it here. So at the end of this loop is where we can get rid of this, or we could just glue it to the end of this function here, right? Number of tests, number of columns, and is that kind of like at the same indentation level? Yes, it is. Cool. So then we're going to change the define to undef, so undefy. Okay. And we have this destination. We did not do that. So ivec2 dst, so the destination. And that should be all we need to get this running, right? So we are hoping, oh, also this range needs to be changed, right? So the range is 0 to 11 and then 0 to 5, right? So we're going from a very small, we're going from a larger to a smaller, right? So 0 to 11, and unlike some of the other tests we were writing, we're not going to do any kind of like weird offsetting, because we don't think, so far I don't think that any of the mistakes are because of having a different origin, right? So we're not even going to worry about the origin. We're just going to keep the problem as simple as possible. So the origin is just going to be 0, 0 for both of these, and we're just working on the squash stretch kind of aspect, right? We're not worrying about any of the translation of the data points. So we got 0 to 5 here, right? So let's change these to 5s. And that should be all we need to do, right? So we can kind of like condense this a little bit so it kind of fits. Make a little bit more visual space. So we have the input range and the output range. And we can give that a roll. And we also have to do this, you know. If dst.x is not equal to dx, or dst.y is not equal to dy, then we have an issue, right? Okay. We'll have to print off what those values are, right? So dst.x so we got dst.x %d\n dst.x, and we got what else do we get? We got dst.y, right? So we got dst.y. And then we can say, well, what do we expect, right? So we can go over here. We can say, well, we got this, and we expected dx and dy, right? So we'll take this. And then we can change this over here. Line up those x's and y's nicely. And then we might also want to do a printf \n between here, so just that we can see this grouping of this and grouping of that, right? And so we can just look at what that is. And then maybe we're going to get a little bit too fancy, and we can kind of like put some stars in here, right? And then over here at the end of it, we can put some stars over here, and then we can, you know, give error message, right? We can crash. Okay, so I think that's pretty good. I think that, I don't know if I really need to keep on looking at that image, but let's try to just give this a run. And then what we're going to do, after we get this running, or if it fails on us, I don't know what's going to happen. Okay, so it looks like called from, it thinks I'm calling a function with the way I wrote my syntax. I don't see anything that I'm doing improper, though. 250, right? So 250 is right here. That's a very odd place for the mistake to be. Because it's like everything's working, and then we get to like column 43 somewhere, and then it's blowing up on us, and I have no clue why it would choose to blow up. I have no clue why it would choose to blow up on line 250. Error, called object I is not a function or function pointer. So it says called object I. Perhaps this is an I and not a 1. It looks like a 1 to me. 250, fragcom.f. 250, right? That's 250 right there. Is there an I somewhere else in the code? Okay, that just makes absolutely no sense to me. Number of tests times number of columns, 16 and 4. We have our commas everywhere they need to be. I have no clue what this is about. I don't understand that at all. 3, 0, right? So the 3 and the 0 right there. It's just like, hey, we're gonna not crash, and then bam. Makes no... I have no clue. I've never seen this before. Called object is not a function pointer. Function or function. So, called object is not a function. You forgot a comma or semicolon somewhere. That is... So I'm going to take my advice that according to my shortcuts, according to how I do stuff, it's saying, you know what, you forgot a comma or a semicolon somewhere, right? Is there any chance that maybe one of these things is not a semicolon, right? Like it's actually a period? Oh, hey, look at that. Yes, we forgot a comma or semicolon. There's one missing from here. We duplicated this block a whole bunch of times. That first comma always screws me up because everything is kind of uniform except for this first comma. And then I try to like write blocks of code all nice and then that happens to me. Okay, so let's give that a shot. Okay, subscripted value is neither a pointer nor a vector. So that's because we just wrote that completely incorrectly because I don't know, right? So test index, no, we use the test index to the base value, and then we use it as an accessor into the unit test code. So, okay, let's give that a shot. So we're expecting that. Well, we're hoping all the tests will pass that we've written so far, but I don't think they are. I think they're actually going to fail because this is actually a test based on the case that we're looking at. So we got DST 189, and we're expecting 1. Holy crap! What the WT and Fs? Okay, well that just makes me curious as to what it thinks the input is. And if we're like, are we like reading into like a invalid region of memory? Because I don't see anything that would give me a 189. Like a 189, seriously? How did I get a 189? That makes no sense. So test index. Number of tests. Well, look at max index for a second. Number of tests times number of colons. Number of columns. What the heck am I doing there, right? So, also, something that also might help is that, you know, if we print off the test index, we would have saw, like, a ridiculous test index. And then we would have been like, I see. So let's, print that test index as well. So that way, when we look at this, next time it crashes, if we see a ridiculous test index, we'll know it's wrong, right? So, but yeah, we just went out into some random memory address, I think, and then, you know, it just tested, right, undefined behavior, right? Okay, so that would say that it passed, right? That's what that says, right? Right, because here we are. Still not looking right, but... Okay, so, let's test over here now, right? So we want to test this top right cell over here. And so we're going to go... Let's kind of do the same thing we did last time, right? So let's... Oh, I see. Okay, so let's just take this and say... We could just copy it all and translate it correctly, right? So the x's, the y's are going to be correct, right? So 0, 1, 2, and 3. Like the y-axis is still the same. It's the x-axis things that need to be changed, right? So you got this 0, 1, 2, 3 on the x. And that's going to be changed to 8, 9, 10, 11, right? So we got 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. That's going to be 8, 9, 10, 11. And then we're expecting to map to 4, 4, 5, 5, right? So 8, 9, 10, 11 is going to map to 4, 4, and then 5 and 5, right? That's what we're expecting. So we could just take this change, right? We could take these changes. We could just shove them in here, right? Because, right? So this is kind of very redundant, right? That's why, would I rather be thorough, right? So, okay, so if we try that, I'm going to expect that all to work. I'm going to expect it just works nicely and it's all great and all good stuff. So now there's 32 tests, so let's add 30, let's put 32 in there, and let's give this a run. And then after we get this running, like after we get this test case finished, we're gonna have to scratch our head and think about what the hell is going on, because not a function or a function pointer. So once again, when we kind of copy pasted, we had to change that just a little bit. Okay. And that passed. Cool. So now the next thing is, let's just keep on going with this, because I think I do want to actually, let's put 100 in here, because I'm getting paranoid. I'm getting paranoid to where it's like, this is working way too well. I'm not making any mistakes. So I'd like to make sure that this crashes when the test fails. So we're just gonna just make that a 100, so we have a test case that would fail. Just to make absolutely sure we're not like... Yeah, okay, cool. Just making sure. Just making sure that that is a thing. Excellent. So now what we can do is we could take all these test cases, and they just need to be shifted down on the y, right? So the y-axis 0, 1, 2, 3, right? That could be changed to x-axis value. So let's just steal all this stuff, right? Let's just copy it all, right? And let's make some room. And we're going to change this to bottom left. And this is going to be bottom left. And then this is going to be bottom right. In bottom right. And before we even refactor the tests at the bottom, let's say, hey, we got 64 tests now. And let's just run it, make sure that all the tests pass, and then we're going to refactor the bottom tests to make sure they're looking at that bottom. So we tried to, you know, cut and paste, and then we forgot about this. Okay, so now we're ready to go. Now we're ready to, unless we changed the top. No, okay, cool. Okay, so all those tests pass, right? All the tests pass, excellent. Now we have to change what we're looking at here. So instead of looking at 0, 1, 2, and 3, so on the y, here's x, here's y, 0, 1, 2, and 3, we're going to look at, this should be 8, 9, 10, and 11, right? So 8, 9, 10, and 11. So we're going to say, hey, you know what? You're 8, you're 9, you are 10, and then you are 11. 8, 9, 10, 11. And then we can take these and we can copy paste them a few times, right? Down here. 8, 9, 10, 11 on the y-axis. And those respectively should be mapping to, if we go over here, we're expecting that to map to 4 and 5, right? 4 and 5. So instead of mapping to 0, 1, 0, 1, it's going to be 4, 5, 4, 5, right? So right here, this is 4, and this is 5. 4, 5, 4, 5. Okay, so let's give that a run and see if that works. And then if that works, I don't know. I think I'll have to, like, I can make a more coarse test case to make absolutely sure that that it's functioning as expected. But it seems to work. It seems like the mapping function is correct. But the thing is that when I fixed up the mapping function the first time, we got more correct looking results. And so that makes me think that the mapping function still isn't completely correct. I think it's the mapping function that's doing this to us. We already sampled 2 pixels from I don't know. I don't know what to do to guarantee that this would be well, we could try this exact test. We could try this exact scenario, right? Instead of beating around the bush, we could we might want to test out this exact scenario. So, right, so this exact, rather than coding a simplified proxy for this test case, for what we're trying to see on screen, we might want to code something that is that explicitly tries to, like, instead of using like a test table, right, we kind of procedurally want to scan through this kind of region of pixels on the 512 by 512, make sure they map correctly, then scan through this region, make sure they map correctly, scan through this region, make sure they map correctly. So we might just want to kind of rebuild that scenario in more detail than we have here. So, so let's close this up. Yeah. So 0, 1, 3, 9. And 01, 01. And we could say 10. Just to make it kind of annoying. This test passes and is a proxy for situation seen in. So this is a proxy for the situation seen in here. We should probably do an exact test that mocks up the situation in yeah. I would say we need to just mock this up, right? So instead of using like a test table, we need to be a little bit more clever about how we're doing it. And we'll make that insertion like, it's still a specific test case, so we could insert it down here and say, you know what? So we could just duplicate this and just say, you know what? SC4, specific case number 4. And then instead of SC3, it's going to be SC4. More accurate SC3 test. So this is just going to be a more, this test is just going to be a more accurate version of this, where you kind of procedurally try to set up this entire environment and pixel by pixel test it, kind of make sure it's absolutely pixel perfect, right? Because the rough proxies are passing our tests now. Like all these possible, this is a lot of tests for just this one function. But if it's not correct, it's not correct, right? So it's like, yeah, it's very bulky and there's a whole bunch of tests, but the tests give us a lot of sanity of mind that the code base is solid, you know? So let's try not to despair that we have a ridiculous amount of test code, and just rejoice that the tests are in kind of a good condition where we know they are, we know they're solid, right? So let's go over here and call this, you know, EV for extern void. Ooh, we don't want to call this extern void, do we? I'm surprised that we got away with that. Can we say extern void and then immediately define it and then it just works? Is that even proper? Well, we can say, hey, it's somewhere else, and then we can immediately define it. That's kind of, that is kind of a... I just realized I was doing that. Extern void. Yeah, that's kind of a... Yeah, and all these functions, I can't believe that's compiling. I guess learn something new. Sure, whatever. I mean, for now, I can't believe that worked. I can't believe this has been working. because that seems like a really stupid mistake. But okay, it worked, so I'm not going to worry about it. So inside here, we're just going to say, ERR to do mock up, and then we can say, right, we'll throw that in there like that, and then we'll give this a run, make sure it crashes, and then we're gonna try to we're gonna stop the stream, and we're gonna do more push-ups. We're gonna try to do like maybe 50 more or 60 more, at least 40, right? So I'm thinking 60, right? So we want to have like a decent. We want to have most of our push-ups taken care of before we. So to do mock up, and then it has this imgur URL. Okay, cool. So that's good. So here's what we're gonna do. We're gonna go clear this. We're going to get status, get add dot, get remote dash v, get push or get status, get commit dash am. Add more mapping tests. Git push GitHub master. And then we'll also push this to, well, no, we added an error message, so it like crashes immediately, so we should not push that up to kanji coder because it doesn't work, right? It needs to compile out of the box if it's pushed up to kanji coder, and it does not. With this error message thrown in, that's not what it does, right? Okay, so let's look at our push-up counter here, and we've done what, only 50? So let's try to get the other 50 out of the way, right? So can we do 50 now, and then we only have less than 50 later, right? Or let's try at least for 50, and then if we feel like doing more, we can do more. But yeah, so this was, oh, sorry, not that. This was not 71, this was 72, right? Actually, no, this was 71. This was 71, yeah, 71. And we're on the PAINT5D sprint. This is video number 139. I'm going to go do push-ups, and I'll be back later.